Today we're going to talk about graphing inequalities and how we graph an inequality. First, we need to know that the graph of an inequality shows all of the solutions of the inequality on a number line. So this statement is really important and will make sense. We will come back to it, but it's basically a number line and it shows all the numbers that are going to make that inequality true. So before we move on, let's review what a number line looks like. Remember, pause this at any time to catch up. So here's an example of a number line. I started it at 0 and I went up 1, 2, 3, 4, and then I made an arrow going off to the right. That shows that the number line keeps going. And then off to the left, 0, -1, -2, -3, -4. And again, the arrow shows that this will continue on forever and ever. If we have numbers when you're going to the right, it means the numbers get bigger, and when you go to the left, the numbers get smaller. So 4 is bigger than 1 because 1 is to the left, so it's smaller, 4 is to the right, it is bigger. In the same respects, even though these are negative numbers, -1 is actually bigger than -4 because -1 is to the right of -4 and -4 is to the left. We'll also be working with fractions and decimals. I just gave you a few examples here of some fractions and decimals. Here I started at 0 and then I went by halves. 1/2, 1, 1.5. And then -1/2, -1, -1/2. And I did the same thing with some decimals. So these were fractions and these are decimals. 0, 0.5, 1, 1.5. And then I went negative, -0.5, -1, and 1.5. Again, pause at any time to keep up. So the other day in our math journal, we talked about our inequality symbols, some key phrases, and we talked a little bit about graphing. I actually just had you draw this and said we would come back to it. And we talked about open and closed circles. First of all, we have the graph of open circles. Open means that it's not shaded in, there's no shading to this. When you see the inequality symbols, such as less than or greater than, you know that if that circle is on that number, that value is not included. This will make more sense in a minute. So let's look at this. If I have the inequality, x is greater than 5. There's my inequality. I ask you all, can I put 5 in here? This is my value because I'm saying the value is not included. So here's my value of 5. Can I put 5 in for x? Can I say x is greater than x? 5 is greater than 5. No, I can't say that. 5 is not greater than 5. 5 is equal to 5, but 5 is not greater than 5. So I could plug in 6 is greater than 5, and that makes the statement true. I could plug in 7 is greater than 5. That makes the statement true. I could also plug in 10 is greater than 5. That makes the statement true. So anytime that you have a value that is greater than 5, it would make this statement true. And you would see an open circle on the number line. So 5 is not included. 5 is not included. So we also have our closed circle. And you will notice here we have the inequality symbols less than or equal to, greater than or equal to. You will notice the difference between the open and the closed circles. Open does not have the equal to symbols, where the closed does. In this closed circle, the value is always included. So let's look at the difference. X is greater than or equal to 5. Could I plug 5 in there this time? I couldn't over here. I could not include 5 here, but could I include 5 on this side? Well, sure, I could include 5 because 5 is greater than or equal to 5. 5 is equal to 5, so I can include 5. So when you're looking at your number line and you see a closed circle, you would know that that value is included in the answer. I could also plug in 6. 6 is greater than 5 or equal to 5? Sure. 7 is greater than or equal to 5? Absolutely. I could do 10 is greater than or equal to 5. Sure. So you can use any of these, but this time you can see that the 5 is included as part of a solution. So we're going to write 5 is included. So let's get to the fun part. Let's get to the graphing. Let's take the inequality, put this up here. X is greater than 7. X is greater than 7. Well, I make my number line. It doesn't need to be perfect. I just make 5, 1, 2, 3, 4, 5 little slash marks. The number I'm working with is 7, so what I do is I just put 7 in the middle, and then I do 2 above and 2 below. So I'm working with the number 7, so I do 5 and 6 on the left side, 8 and 9 on the other side. It is not necessary to write a number line that is 10, 15 numbers long. It's okay, we only need 1 or 2 or 3 numbers. So I look to see, and I say X is greater than 7. Since it's my number that I'm working with is 7, I'm going to go ahead and I'm going to put a circle on 7. And then I ask myself, is it an open circle or is it a closed circle? If I go back to this page, you will notice the less than and greater than signs that did not have the equal to is an open circle. So I'm going to leave that as an open circle. And X is greater than 7. Well, if something is greater, it's bigger. So we're going to go off to the right because we want our numbers to be bigger. So we could plug in 8 for X. We could plug in 9 for X. We could plug in 10 for X. We could plug in 100 for X. We could plug in any of those values for X. So when we said that the graph of an inequality shows all of the solutions of the inequality on a number line, we're showing you that X can equal anything that's above 7. Let's try another one. Again, pause at any time to keep up. X is greater than or equal to 25. X is greater than or equal to 25. So I'm going to draw my graph, my number line. 25 is my number that I'm working with, so I'm going to put 25, and I'm going to put 26, 27, I'll do 24, 23. All right, so I quickly drew my graph, did not need to spend a ton of time on it. X is greater than or equal to 25. So I'm going to put a circle on 25 because that's the number I'm working with. It's greater than or equal to. Since it's greater than or equal to, it's including 25. So I'm going to color in 25. And it says X is greater than. So the answer for X that we plug in here has to be greater than 25 or equal to 25. So I can go ahead and draw my arrow to the right. One of the neat things about when you are reading this, x is greater than or equal 25, if you notice in this inequality symbol, the arrow here is kind of pointing off to the right. Your arrow goes to the right. Same with this one. The arrow is pointing to the right. The arrow is pointing to the right. So the line's going to the right. This only works if the variable is on the left side of the inequality symbol. So x is on the left side, so therefore that would work. If you want to double check your work. Let's try another one. Let's try x is less than or equal to 16. Let's draw this out, and I'm going to make 5 slash marks. Put 16 there, 2 above it, 17 and 18, and then 2 below it. X is less than or equal to 16. So I'm going to start out with putting my circle on 16. It's less than or equal to, so since it's or equal to, that means 16 is included in my solution, so 16 would work. And as x is less than means I'm getting smaller, so I go to the left. I'm going this direction. I also look, my arrow's pointing that way, my arrow's pointing that way, so I'm doing good. What if I were to try to graph a fraction? Well, if I have x is greater than or equal to 1/2, here you will notice I have 0 and then a line and 1 and then a line and then 2. Notice that the lines in between are not labeled, but I can look at that and confidently know that that's halves. These are broken into halves because they're in the middle. Just like if this was a 3, they'd be broken into thirds. If it was a 9, it'd be broken into nines. So it's x is greater than or equal to 1/2. So I'm going to locate 1/2 and draw my circle. So I look here, here's 0, here's 1/2. Right there's 1/2. It's greater than or equal to, so since it goes on 1/2, because this is where my 1/2 is, it wasn't labeled, but I know that that's where it is. Or equal to. So it says x is greater than or equal to. Greater than means getting bigger, or equal to, so my solution has to be greater than. So I'm going to draw my arrow off to the right. And here you will notice my arrow goes to the right. Pause here if you need to catch up. There's more, okay? So let's see. So we've had x was greater than 7. We had x is greater than or equal to 25. We had x is less than or equal to 16. And we had x is greater than or equal to 1/2. You will notice that the variable was on the left side of the inequality symbol, right? It's all on the left side. But wait, what if the variable is on the right side? What if the variable is on the right side? All of our values were on the right side here. Our variables were on the left side. So let's look at a right side and see what happens. So what if I had 5 is less than x? Notice my variable is now on the right side. The variable is on the right side. X is less than, it's 5, excuse me, I'm sorry, 5 is less than x. I'm going to go ahead and draw my number line just like I would with any other one. My 5 little slash marks, and then I have 5 as my number, so I'm going to do 5, 6, 7, and then 3 and 4, just like I did when the variable was on the left side, but now it's on the right side. So when I read this, I would, and if I were to read this from left to right, because up here I started saying x is greater than 7, x is greater than or equal to 25, x is less than or equal to 16. But down here I'm going to say 5 is less than x. So I would read it as 5 is less than x. And again, I'm reading that just left to right, like you would a book. But when we're trying to graph an inequality, you need to start with the variable. So I'm going to read it, I'm going to read it from left to right. I'm going to start with the variable. I'm going to say x, oops, wrong color. X is, but I'm going this way now. X is greater than 5. So before, when I'm going from left to right, it says 5 is less than x. 5 is less than x. But when I'm coming the other direction, now x is greater than 5. And this is the one we are going to want to graph. X is greater than 5. X is greater than 5. So I'm going to put my circle on 5. It's going to be an open circle because it's not including it. And x is greater than. Greater than means I go to the right. Now our little trick that we learned when the variable was on the left does not work, because you will notice my arrow is pointing to the left here, but I'm going to the right. A good little key thing to remember is that since it's going to the left here, the variable is opposite, you go the opposite direction. So it doesn't flow like the variable on the left, but if you just remember that since it's flipped and the variable's on the opposite side of where it was, then you would flip it and go opposite. But a good key thing would be to read it, x is greater than 5. That would be your answer. Let's try another one. -3 is less than or equal to x. -3 is equal to, or less than or equal to x. So I'll put -3 in the middle because that's what I'm working with. So I'm going to go -2, -1, -4, -5. Remember, we're working with negatives, so as we move left and right, the numbers are a little different. So I'm going to start with -3. There you go, -3, there's my circle. Less than or equal to, it's shaded in, but my variable is on this side. So let's read it and see what we need to do. So if I'm reading it from left to right, I read it as -3 is less than or equal to x. -3 is less than or equal to x. But if I start with the variable and read it backwards, I have x is Now I'm reading it backwards. Opposite of less than is greater than or equal to -3. So now my less than becomes greater than. X is greater than or equal to 3. Again, the trick, since the variable is on the opposite side, this arrow is kind of pointing to the left. Since it's on the opposite side, we're going to go to the right. One more example that I want to show you is if we have an improper fraction. It's important to remember to make that improper fraction a mixed number. So I have 8/3 is greater than or equal to X. Just gonna draw my number line, but I'm not gonna do anything with it yet. Just gonna draw my 5 slash marks. Before I can actually graph this, I need to know where 8/3 is. So I'm going to change my improper fraction to a mixed number. So I'm going to change my improper fraction, which is what I have right here, my 8/3. I'm going to change it to a mixed number. So I take my 8/3, and as you remember, when it's bigger on top, it's a division problem, so it becomes 8 divided by 3. Well, 3 goes into 8 2 times. 2 times 3 is 6. I'm going to subtract and get 2, remainder of 2. So my answer is 2 2/3. That's my mixed number, because I take my 2 whole groups that I made, my remainder of my 2 of my 3. So now really I have 2 2/3 is greater than or equal to X. All right, so now I have my little slash marks, right? And I have 1, 2, 3, and I'm going to put -1, -2. Go ahead and do that. And then since I'm doing a mixed number, so I'm doing a whole number of 2, and then I have 2/3 of that, I'm going to just make 2 little slash marks between each one, because I'm breaking it up into thirds. So now I have to find out where do I put my circle. Well, I have 2, here's 2, and then I have 2/3. So I have 1/3, 2/3. So my circle is going to go right here because there is my 2/3. So I have 2 is my whole number and 2/3. So it's going to fall between 2 and 3. But now I need to look to see how am I going to graph this, because it's 2/3 is greater than or equal to X. Again, my X is on this side. But before I do that, I have to look, is my circle open or closed? Well, since I have my or equal to sign, it's closed because I am including 2 2/3. And I'm going to read it backwards. X is less than or equal to 2/3. So I'm going to go less than, get smaller. Again, the trick is, if you can't remember, look at the direction of the arrow here. It's going to the right, but since my variable is on the right, it's opposite, it's flipped this way. I hope this helps you understand better how to graph inequalities.